Today we're going to talk about function composition and what a composite function is. So a composite function is combining two functions. So if you think of composition, it's made up of something, okay? You're combining all of these different materials, all right? So that's what a composite function is. It is read as f of g of x and g of f of x. So this open circle here means composition, okay? Remember the closed circle means multiplication, so there's the distinction there, okay? You can also, I call these fog and goff, all right? So f of g of x is f, the first function here, that's your outside, okay? So if you think about like a Russian nesting doll, how you have all of these dolls within each other, that's a composite function. You have a function within a function. So the first letter, that's your outside function. The second letter, that's your inside function. So if you have f of g of x is your inside, and f is the outside, okay? You can also switch it around to where you have g of f of x. All right, so g would be the outside function here, and f is the inside. Okay, to evaluate these, you evaluate the inside function first. So whatever f of x is, if you're asked to plug in a number, you evaluate that inside function. Then, whatever value you get, you plug that into the outside function. And this is going to make more sense whenever I go through examples. Something to keep in mind, though, is that fog does not always equal goff, okay? So they are not the same thing, and I will show you an example of how they're not. So let's look at a table here. So I've given you a table of x values, f of x values, and g of x values, okay? So we are asked to find goff. So g is your outside function, and f is your inside function. So we are going to evaluate f of 1 first, okay? So if I look at the table there, when x is 1, what is f? Well, that's 2, okay? So if f of 1 is equal to 2, then that means that I plug in 2 into g, all right? So if I look at the table, where x is 2, what is g? That is negative 12. So g of f of 1 equals negative 12. Now let's look at when we're given an equation. So if f of x is equal to x minus 5, and g of x is equal to x squared, find g of f of negative 3. Okay, so g of x is going to be our outside function here, and I think I got my colors backwards, but we'll work with it. So g is going to be the outside, f of negative 3 is going to be the inside. So first things first, evaluate f of negative 3 first. So if I plug in negative 3 into f of x, I get negative 3 minus 5, which gives you negative 8. So now, that's what I plug in to g. Okay, so now I would have g of negative 8. So that would be negative 8 squared, which is a positive 64. So g of f of negative 3 is equal to 64. Let's do another one. So if g of x is equal to 2x and h of x is equal to x squared plus 4, find g of h of 1 and h of g of 1. So this is where you're going to see that g of x is not equal, or I'm sorry, g of h is not equal to h of g. Okay? So in this first one here, g is going to be the outside function. So let me rewrite this. So I have g of, that's a really big composition function there, g of h of 1. So that is equal to g is your outside, and then h of 1 is your inside. So if you evaluate h of 1, that is 1 squared plus 4, so that is 5. So next we evaluate g of 5, because that's what we plug in. So over here, if I plug in 5 into g, well, 2 times 5 is 10. So g of h of 1 is 10. Let's flip it. Let's look at h of g of 1. So now h is going to be on the outside, and g is going to be on the inside. So if I find, this would be, I'm sorry, I need to, that is of 1, not of x. So if I evaluate for g of 1, that would be 2 times 1, which is just 2. So now that's what I plug in to h of x. Okay? So now I have h of 2. So if I plug 2 into h, 2 squared is 4. 4 plus 4 is 8. So h of g is 8. So notice that these are not the same thing. Okay? If they happen to be the same, it is a happy coincidence. So now let's look at what happens whenever we don't have numbers inside the parentheses. Okay? So recall that if I have f of x is equal to x squared plus 1, if I have f of 1, that just means you plug in 1 in for x. Okay? If I had f of 2, then you plug in 2 for x. Okay? So what would happen if I plugged in 2x inside those parentheses? So now, normally where I would have my x, I'm now going to substitute 2x. Okay? So if I simplify that, I would get 4x squared plus 1. Okay? If I substituted in here negative x, so instead of writing x in my original function here, I'm going to write negative x. Well, negative x squared, negative times a negative is a positive, so you would just have x squared plus 1. Okay? So now here's what I want to show you. That if you have f of x, which is equal to x squared plus 1, our same function, and I'm going to say that g of x is equal to negative x. I am going to find f of g of x and g of f of x. So no longer do we have numbers, now we just have the variable x. So with fog, my f is the outside, okay, which means that g of x is the inside. Well, if g of x is equal to negative x, that's what I plug in inside my f, okay? So just like what we did before, f of negative x, if I plug that in to where x should be in my f of x function, this is what I get. Okay? We can flip it around to where g is now on the outside and f of x is on the inside. So if f of x is equal to x squared plus 1, that's what I plug in to g. So over here, and I'm going to draw an arrow to hopefully show you, instead of writing x, I'm going to have negative and then I plug in whatever is inside the parentheses there. Okay? If you simplify that down, which means distribute, you would get negative x squared minus 1. So that is g of f of x. So that's how you do composite functions whenever you're not given a value inside the parentheses.